So let's count it all again. So recap, I'm not going to repeat it. We have discussed it too many times. कि पिछले lecture में we were counting number of handshakes, number of seating arrangements, number of possible lottery tickets, number of possible hands in the game of card, and number of possible matches in chess. जी हमने काउंट किए थे, बार बार किए थे, and we had to be very careful not to count things multiple times. हमें counting में, over counting में we have to be careful. We want exact number कि कितने possible scenarios हो सकते हैं. ठीक. For example, remember this our hero from PSL. So I have taken this snapshot of PSL table. I mean before it was over. So at this moment, how many matches have been played? In this column, you see these are matches of 6 teams. So जहाँ पे कितने matches हो चुके हैं? You can answer, turn on your mic or just type in the chat box. So just count कितने matches हो चुके हैं? Anybody? Please count how many matches have been played so far. कोई बात नहीं, अगर आंसर गलत भी हुआ तो you are far away from me, मैं आप पे कुछ नहीं कर सकता. I will just correct the answer. Okay. So how many matches have been played so far? How many matches have been played so far?
48.
फातिमा 6 नहीं, 6 तो टीमें हैं हमारे पास. हमारे पास मैचेस कितने हैं? 48. हाँ, someone is saying 24. So Fatima is saying 48. देखिए, let's count number of matches. It's exactly handshaking problem. Handshaking में जब we were counting handshakes, तो एक handshake कितने लोग उसमें involve होते हैं? They involve 2 people. So if we are counting individual handshakes, we have to divide it by 2. यहाँ पे अगर हम individual matches count करते हैं, 7 plus 9 plus 8 plus 9 plus 7 plus 8. This is going to be 48. लेकिन एक मैच में 2 teams involved होती हैं. So it means over here there are going to be double counting. We have to divide it by 2. So answer should be 48 divided by 2 is equal to 24, because each match involves 2 teams. अगर सिर्फ एक मैच होता मुल्तान सुल्तान का और पेशावर ज़ल्मी का, so we would see one match of मुल्तान सुल्तान and one match of पेशावर ज़ल्मी. तो यहाँ पे भी 1 लिखा होता, जहाँ पे भी 1 लिखा होता, लेकिन मैच तो एक ही हुआ ना, 2 मैचेस नहीं हुए. So these are individual counts of each team, but each team has played match against each other. So हर एक मैच यहाँ पे 2 बार काउंट हुए. So very much be careful of over counting. हम टीम पे over counting नहीं करेंगे. ठीक. So then in assignment we were discussing about subsets. Sets are important. Sets are the building block of our mathematics. Everything consists of sets. So we were counting number of subsets. हमने assignment में भी किया. So let's look at it in more detail in this lecture. Suppose we have a set ABC in which we have 3 elements. तो कितने subsets possible होंगे? Anybody can answer? Can anybody answer how many subsets would be there? If we have 3 elements ABC, how many subsets are there? 7. 7 से एक ज़्यादा होगा. So it should be 8. 8 is correct answer, because there's also empty set there. If we start from empty set, then single element set, then double element sets, and then 3 element set. For example, just see how many subsets of empty sets are possible. जब हमारे पास empty set है, तब इसके कितने subsets possible होंगे? how many subsets of empty sets are possible? One. So there will be one possible subset which is empty set itself. Okay. If we have single element set A, so we will have two subsets, empty set and the set A itself. And if we have two elements in a set A, B, so how many subsets are possible? Empty set, single element set, which is A and B, and then double element set, two element set A, B. So we will have four subsets. So when we have three elements A, B, C, we are going to have four subsets. कौन से? We have these empty set, set A, B, C, AB, BC, AC, and ABC. So over here we can observe if we have zero elements, empty set, we have one subset. If we increase by one, we get two subsets. If we increase element, one more element, our subsets are doubled. This become 4. अगर हम एक और element increase करते हैं, number of subsets are 3. Number of subsets are doubled. 2 times हो गया 8. So अगर हमारे पास 4 elements हैं, then we will have double of 8 means 16 subsets. If we have 5 elements, then we will have 32 subsets and so on. So every time when we are increasing our element by 1, our number of subsets are increased by 2 times. And we can see, देखिए हमारे पास यहाँ पे कितने elements हैं? 3 elements हैं, A, B, C. So we are going to have these 8 subsets. If we increase one more element over here, if we have an element D, तब हमारे पास subsets कौन से होंगे? These 8 subsets would be there. ये तो फिर भी subsets होंगे ना. And then we have some additional subsets. वो कौन से होंगे जिसमें D involve हो रहा होगा? So we can simply count those subsets by appending D with each one of these subsets. जहाँ पे empty set है, empty set के साथ when we place D, we will get D. Over here we will get AD, BD, CD, ABD, BCD, ACD, and ABCD. So we will have 16 total subsets. We have 8 of these subsets and further 8 more subsets. वो कौन से होंगे? इन्हीं के साथ आप D append कर दें इनके साथ. So we will get 16 subsets. And if we have a fifth element E, so जो आपके पास 16 subsets आ गए वो तो होंगे. अब इन सब subsets के साथ E append कर लें. So we will get 16 more subsets. We will have 32 subsets. Fine. So important observation. Whenever we increase elements, number of elements by 1, our number of subsets become double. So if we have n elements, we are going to have 2 raised to power n subsets. So we make a theorem. A set with n elements, it has 2 raised to power n subsets. Okay. So it's very much similar. You know, power set, size of power set is equal to 2 raised to power n. So if you remember power set, so power set क्या होता है? It is set of all subsets. Okay. So size of power set कितना होगा? Number of possible subsets. So which is equal to 2 raised to power n. ठीक हो गया? So इसका हम थोड़ा सा और further देखते हैं. Look at this picture. So we say a set with n elements has 2 raised to power n subsets. So how I mean we make this claim. So we try to elaborate, explain this claim. So this picture is called ये ग्राफ है जिसमें हमने ग्राफ स्टडी किया था. ग्राफ क्या होता है? Nodes and edges. So it's a very particular kind of graph. This is called tree. A tree structure. So we can see it's like upside down tree. ऊपर हमारे पास जो node, first node is called root node, and then we have bottom nodes. These are called leaf nodes. So you can think of it as an upside down tree. So इस tree में क्या है कि we are making decision whether particular element belongs to subset S or it doesn't belong to subset S. So we take one element by element from our set. So our set consists of A, B, C. So we take the very first element, A. So we see over here, we ask a question whether A belongs to subset S or not. S is our subset. So हम देखते हैं कि A S से belong करेगा कि नहीं करेगा. A belongs to S or not, subset S. If it is yes, we move towards left. If it is no, it doesn't belong to subset S, it's not part of subset, then we move towards right. So on next level, we will ask about B, whether B belongs to subset S or not. If it belongs to subset S, we move towards right. If it doesn't belong to S, we move towards right. Then we ask about element C on next level, whether C belongs to S or not. If yes, move towards left. If no, move towards right. So on each node, we are going to make a decision whether this element belongs to subset or it doesn't belong to subset. So that's why this structure is called decision tree, because at each level we are going to make a decision, yes or no, yes or no. So this is called a decision tree. और हमारे पास कितने decisions हैं? There are two decisions, either yes or no. So we have binary decision. We have two decisions, binary, two. So this is called binary decision tree. You will come across this thing often and many times in your computer science. Binary decision tree. So at each node we are going to make a decision whether element A belong to subset or not. And then at the end we see कि हमारे पास कौन सा subset आ गया. Suppose we walk along this branch or walk along this path. So A belong to S, yes. B belong to S, yes. C belong to S, yes. We get a subset A, B, C. Or if C doesn't belong to S, then we get A, B, and no to C. So we get A, B. Over here we can see A belongs, B doesn't belong. C belongs, so AC, or C doesn't belong, so we just get A. On the right side from root node, so A will not belong to A, so we exclude A. Then we ask about B. If it belongs, yes. C belongs, yes, we get BC. C doesn't belong, we get only B. And if B also doesn't belong, only C belongs to subset, we get C. And if C doesn't belong to S, then we don't have A, we don't have B, we don't have C, so we get an empty set. Fine. So how many subsets are possible? We just count the leaf nodes. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 leaf nodes. So we are going to have 8 subsets. हमने तमाम possibilities count किए ना इस scenario में. So possible subsets हमारे पास 8 आ गए. So we observe over here that at each level, our nodes are going to increase by 2 times. यहाँ पे हमारे पास 8 node है. So we make a binary decision. At next level, we are going to have 2 nodes. For each node, we are going to have binary decision. So we are going to have 2 more nodes from each node. So we will have 4 nodes. So then we are going to have again 2 more nodes. So we are going to have 4 times 2, 8 nodes. So at each level, our nodes are going to increase by 2 times. So how many levels we have? 1, 2, 3. So we have 3 levels. So we are going to have 2 times 2 times 2, 8 nodes. So we are going to have 8 nodes every time at the end. So whenever we are going to have one more element, we are going to have our number of nodes 2 times. So 2 times 2 times 2, 2 raised to 3, 8. If we have n levels, we will have 2 raised to n leaf nodes. So in decision tree, we have to count number of leaf nodes, and how many leaf nodes will be there? 2 raised to n. And leaf nodes पे हमारे पास क्या आ रहे होते हैं? At leaf node we are going to have at leaf nodes we are going to have subsets. So how many leaf nodes are there? These are equal to number of subsets. So how many subsets are there? 2 raised to n. So we are going to have 2 raised to n subsets. So our theorem was a set with n elements has 2 raised to n subsets, and we showed it with the help of decision tree that yes, we are going to have 2 raised to n subsets. So so far so good. Any question? So far so good. Any question? If you have any question, you can ask now. Lovasz is asking, sir, class कब होनी है? बेटे class हो रही है. So any question so far? If no, so we move on. So let's move on. Okay, thank you, sir. So let's count it in an alternate way. There is another way of counting. So that's also very important way how we count. This is through binary string. हम binary strings के जरिए count करते हैं. Binary strings के जरिए हम कैसे count करते हैं? We list all our subsets in a particular order. और उस order को we represented with the help of a binary string. So binary string क्या होती है? Binary string is a string of zeros and ones. We have only zeros and ones in this string. This is a programming way you define string of characters. So over here we don't have character string. We talk about binary string. This way we have only zeros and ones. So it's actually binary representation of our decimal numbers. So we map binary strings to sets, and we will see how many sets are there. And this mapping is very interesting because if we we are listing in a particular order. So if we say what will be the set number 5, so we will immediately say, oh, set number 5 will be this one. ठीक है, किस तरह वो अभी हम देखते हैं. For example, if we are asking you a question, we list down all the subset in a particular order, and then we want to know what is the 233rd subset in the list. We are assuming that set has 10 elements. If it has 10 elements, so how many subsets are possible? 2 raised to 10, 1024. So out of 1024, which will be 233rd subset. So in that list, we have to see which is 233 number subset. So ये हम किस तरह करते हैं? Let's talk about this thing. So before we go to this question, where we have 10 elements, let's talk about this simple set A, B, C. Okay. So we have 3 elements A, B, C. How we list them? We list them with the help of a binary string. So we represent A, B, C with the help of a binary string of length 3. It has length 3 binary string. So for very first place in binary string, very first digit of binary string, it will corresponding to A. The second bit, binary string consists of bits, 0 and 1. The second bit will corresponding to B, and third bit will correspond to C. If A is there, we will make the value of bit 1. If A is not there, we will make value of bit 0. इस तरह B के अगर तो B सबसेट में प्रेजेंट है तो हम सेकंड पोजीशन पे मार्क करेंगे 1. If B is not there, we will mark it by 0. And then for C, if C is there, we will mark it by 1. If C is not there, we will mark it by 0. So let's encode all the subsets with binary strings. किस तरह? जैसे अभी मैंने आपको बताया, if an element is present, we mark it by 1. If the element is not present, we mark it by 0. For example, A, C. So इसमें A और C present है, B is not there. So we have a binary string of length 3. A is there, we mark it by 1. B is not there, we mark it by 0. C is there, so we mark it by 1. So our binary string is 1, 0, 1. If we have B, so A and C are not there, only B is there. So A is 0, B is 1, C is 0. A, B, C. So all A and B, C are present. So A is 1, B is 1, C is 1. Fine. So let me ask a question. What will 0, 0, 0 correspond to? Which subset? If we have 0, 0, 0, so it will correspond to which subset? कौन सा subset हमारे पास?
Empty.
Yeah, it will be empty. 0, 0, 0. A is not there, B is not there, C is not there. That's good. Thank you. So I list on all subsets of A, B, C, empty set, and then all subsets. So let's look at this from here. 0, 0, 0 correspond to empty set. 0, 0, 1 is C. 0, 1, 0 is B. 0, 1, 1 is BC. So see, I'm just enlisting numbers from 0, 1, 2, 3, 4, 5, 6, 7. So 1, 0, 0 is A. 1, 0, 1 is A, C. 1, 1, 0 is A, B. C is not there. 1, 1, 1 is A, B, C. Fine. So if someone asks which, what will be number 5 subset? So we see 5 correspond to 1, 0, 1 in binary. So it's A is there, B is not there, C is there. If someone say what is subset number 3, so 3 is 0, 1, 1. So it means A is not there, B, C is there. ठीक हो गया जी. So over here again we have some interesting observations. So what will happen if we have n element in the set? So we will have how many subsets? 2 raised power n. किस तरह? N elements हैं, तो corresponding to each element we have 1 bit. Okay, so how many bits are there? N bits. So n bits हैं. So how many binary strings are possible? 2 raised power n. If there is 1 bit, so we have 2 raised power 1 is equal to 2 values, 0 or 1. If we have 2 bits, so how many values are possible? 4 possible values, 0, 1, 2, 3. 0, 0, 0, 1, 1, 0, 1, 1. And if we have 3 binary, length 3 binary string, we have 3 bits, we can represent up to 8 numbers, 0 से लेके 7 तक. If we have length 4 binary string, we have 4 bits, we can represent up to 16 number. If we have length 5 binary string, we can represent up to 32 numbers. So every time we are increasing 1 bit, हमारे numbers की range double हो जाती है. Fine. So if we have length 10 binary string, we have 10 bits, we can represent up to 1024 numbers. कौन से number? From 0 up till 1023. So if we have length n binary string, we can represent up to 2 raised power n numbers. और वो कौन से numbers हैं? Starting from 0 up till 2 raised power n minus 1. जिस तरह यहाँ पे भी हम कह रहे थे, it was 2 raised power 3 minus 1, 2 raised power 4 minus 1, 2 raised power 5 minus 1, 2 raised power 10 minus 1. So last number, पहले number हमारा 0 होता है, आखिरी number 2 raised power n minus 1 है. Fine. So if we have a length n binary strings, we have how many numbers? 2 raised power n. But each binary string represents one subset, right? Each binary string is representing one subset. So how many subsets are possible? How many numbers are there? So Someone is saying to repeat. Okay, so I'm just repeating quickly. So we are talking when we have binary strings. Each binary string represent one subset. Fine. We are representing subsets with the help of binary strings. So each subset represent one subset. And whenever we increase one bit, so how many binary strings are possible? It is increased by 2 times. अगर हमारे पास लेंथ 3 की बाइनरी स्ट्रिंग है, we can represent up to 8 numbers. कौन कौन से नंबर? 0, 1, 2, 3, 4, 5, 6, 7. 7 is equal to 1, 1, 1. 0 is equal to 0, 0, 0. So 0, 0, 0 से लेके 1, 1, 1 तक we have 8 choices. Sorry, we have 8 numbers. अगर हम बाइनरी स्ट्रिंग की लेंथ 1 बढ़ा देते हैं, from 3 we make it up till 4. So numbers की range from 8 it becomes 16. It becomes double. If we increase length of binary string by 1, it is length 5. हमारे पास numbers are increased by 2 times. 16 से ये 32 पे आ गए. And if we keep on increasing number of bits by 1, our number range will keep on increasing 2 times. Hर times 2 से multiply होती जाएगी. So for example, if we have length 10 binary string, we can represent up to 1024, which is 2 raised per 10 numbers. So if we have length n binary string, we can represent up to 2 raised to power n numbers. ठीक. और हमने बात क्या की थी कि each binary string correspond to one subset. Each binary string correspond to one subset. So if there are 2 raised per n binary strings possible, तो कितने subset possible है? 2 raised per n subset, because there is kind of 1-to-1 mapping. So number of subsets of a set with n elements can be 2 raised per n, because number of binary strings with n bits, how many possible? 2 raised per n binary strings are possible. 2 raised per n binary strings are possible, means 2 raised per n subsets are possible. Fine. So back to our question. So what will be 233rd subset in this list if we have 10 elements in the set? So binary form of 233 is going to be, if we represent it with 10 bits, 0, 0, 1, 1, 1, 0, 1, 0, 0, 1. So this binary string corresponds to which subset? If we have 10 elements, A1, A2, A3, up till A10, these are our elements in the set. So which elements will be present? First is 0, so A1 should not be there. Second bit is 0, so A2 should not be there. Third bit is 1, so A3 should be there, A4 should be there, A5 should be present, A6 is 0, so A6 shouldn't be there. A7, 7th bit हमारी 1 है, so A7 should be there. A8 and A9 should not be there. A10 should be there. So 233rd subset क्या होगा? A3, A4, A5, A7, A10. जहां पे 1 है वो वाले एलिमेंट्स प्रेजेंट होंगे, जहां पे 0 है वो एलिमेंट्स प्रेजेंट नहीं होंगे. फाइन. 233 से हम बाइनरी स्ट्रिंग कैसे लेते हैं? आई थिंक यू कैन डू इट बाय इट्स सिंपल डेसिमल टू बाइनरी कन्वर्जन या बाइनरी टू डेसिमल कन्वर्जन. इफ यू फॉरगेट दीज थिंग्स यू कैन जस्ट रिकॉल. हम नंबर को 2 से डिवाइड करते हैं एंड वी आर जस्ट मेंटेनिंग रिमाइंडर्स. रिमाइंडर 1 आएगा, 0 आएगा. If you forgot these things, so please on YouTube you can find simple tutorials, videos, how to convert decimal to binary and binary to decimal. ये आपको पता होना चाहिए. You can just, आपको आसानी से YouTube पे videos मिल जाएंगे. ये आसान से काम है. So for 233 we have found कौन सा सबसेट होगा. So over here there is one interesting observation again. For every subset, we have exactly one corresponding binary string. We have exactly one corresponding number. And corresponding to every number, we have exactly one subset. Corresponding to every number, every binary string, we can represent it with exactly one subset. So it's one-to-one mapping. It's also called bijection or one-to-one correspondence, one-to-one mapping. So whenever we are given some subset, we can tell which binary number correspond to this subset. And if we are given one binary string, we will know which subset is corresponding to this binary number, binary string. Okay. So a one-to-one mapping, it is about like functions. अगर आपको याद हो onto function, one-to-one function. अगर नहीं याद तो in the course we will discuss it sometime. Fine. So before moving further, any questions so far? So good. If there is any question, please ask now. Otherwise, we move to next slide. Any question? It seems no question, so we can move forward. No, sir. Thank you, Fahad. So far in the class, I can see 16 people are there. 16 people are not there. So at the end of the class, we will make attendance. So far, let's continue. Thank you, Zaid. So, okay, let's move to next topic. Next question. So now we talk about sequences. So I've shared the reading of the book. It's section 1.5 of the book. Chota sa, just 2 pages. Please go through the reading. So now we are counting sequences. हमने पहले भी count किए थे. अभी हम दोबारा count करते हैं. How we count sequences? Now instead of subsets, we are counting sequences. So the question is, suppose we want to determine the number of strings made out of A, B, C. हम कितनी strings बना सकते हैं A, B, C के साथ? If A and B and C, these can be repeated. Actually, this is very much similar question that we did it in assignment. In assignment question क्या था? How many words of 8 characters are possible? If we have 8 characters, कितने words possible हैं? So we have alphabet size 26. So if we have 8 characters, at each character position, we have 26 options. So for the very first position, we have 26 possibilities. Zaid Arshad, ये uploaded है ना slide? जी बेटा आपके portal पे upload हो जाएंगी. So alphabet size क्या है? 26. So at very first position, we have 26 choices, A, B, C, D up to Z. Corresponding to each one of this choice, we have 26 choices for second place. So for first 2 place, how many choices we have? Possibilities 26 times 26. So corresponding to each this pair of characters, again we have 26 possible choices from A to Z. At 4th position, again we have 26 choices, and at 8th position, again we have 26 choices. Total हमारे पास words कितने हो गए? 26 times 26 हम 8 times इसको multiply करेंगे. So we get answer 26 raised to power 8. ठीक हो गया? This was a question and assignment. So let's go back to this question. So suppose we want to determine the number of strings, number of words of length n. अब हमारे पास A से लेके Z तक नहीं है, हमने अपना alphabet का size छोटा कर दिया. We just have 3 characters, A, B, and C. With A, B, C, how many possible words are there? How many possible strings are there? How many possible sequences are there? So for the very first place, we have three choices, A or B or C. For second place, again, we have three choices, A or B or C. So till here, how many choices we have? 3 into 3, we can have 9 possible strings of length 2. For third place, again, we have choices A, B, C. So it becomes possible 3 into 3 into 3, 81 possible words. And for nth place, again, we have three choices. So total हमारे पास कितने words हो गए, कितनी strings हो गई? 3 times 3 times 3 times 3 times 3. So total are 3 raised to power n. So we get 3 raised to power n possible words, 3 raised to power n possible strings, 3 raised to power n possible sequences. So let's make it a generalized version. ये वही है जो अभी हमने डिस्कस कर लिया. So possible strings are 3 raised to power n. So let's make a theorem. The number of strings of length n composed of k given elements is k raised to power n. Question में k की value 3 है. We have 3 elements, k given elements. So how many given elements are there? 3. So k is equal to 3. How many possible strings are there? 3 raised to power n. या इस question में value of k is 26. हमारे पास 26 elements हैं and value of n is 8. See? So we have k raised to power n, 26 raised to power 8 possible sequences. So if we have k elements and the length of string is n, so how many possible strings are there? K raised to power n. Fine. So any questions so far? If no questions, so let's generalize this thing. Mia Noman Ahmed present. Thank you, जनाब. हम attendance class के end पे लेंगे. So stay with us for half an hour more. So let's generalize our this rule. So I know we discussed this question. Suppose we have a database with 4 fields. We have a database with 4 fields. So how many possible entries are there? So in this database, we have 4 entries. The first entry is a k character string. This could be the name, which has 8 characters. Then we have gender, it could be male or female. Third entry is date of birth. Date of birth is months, dates, or years. So, and the last entry is job code. In job code, we have 13 possible jobs. So how many possible entries in the database? So first of all, we have to count how many names could be there. So names, we represent each name with 8 characters. In reality, names could be shorter or longer, but over here, we are simplifying things. Each name can be represented by 8 characters. Gender, each name could be either male or female. So we have 2 possible genders. Date of birth, so we have months, 12 possible months. Days, we assume that each and every month consists of 31 days. Years, so we have 100 years. So let's see one by one. First of all, how many names are possible? Any answer? So how many names are possible? G. How many names are possible? Any answer? अरबाज कितने नेम पॉसिबल होंगे? दानियाल, सुल्तान, कितने नाम पॉसिबल हो सकते हैं? तैयब, how many names could be there? Aklema, Hanif, how many names are possible? Please answer. 8 character length. How many names are possible? How many names are possible? जैद आप बता दें, जैद अरशद. Since 8 power n. नहीं देखें, करेक्टर हमारे पास अल्फाबेट्स 26 है. So it's exactly this question. 8 characters के हमारे पास कितने words possible हैं? So names of length 8, it should be 26 raised to power 8. 26 raised to power n नहीं, 26 raised to power 8. We have 8 character length. ठीक हो गया? Then corresponding to each name, we have gender. Either it's male or female. So we have only 2 options. For gender, 2 options, 2 possibilities. Fine. So if I ask till here, for the first 2 fields, how many entries are possible? With the name and gender only, we have how many choices so far? Fatima Rahman. So far, if we are just counting gender and character names, so how many possibilities we have so far? So anybody can answer? Plus 2 name, beta, multiplied by 2, because corresponding to each name, it could be either male or female. तो हम उसमें add नहीं करते, we multiply it. ठीक है? Thank you for your answer, but answer should be 26 raised to power 8 times 2. Because corresponding to each name, this name could be male, this name could be female. तो हमारे total entries double हो जाती हैं. कि तमाम नाम 26 raised to power 8 names, these are all male, and then all these names, these are all females. So it becomes 2 times 26 raised to power 8 into 2. Fine. Now let's come to date of birth. How many date of births are possible? हमारे पास months कितने हैं? Months equal to 12 and days equal to 31. तो टोटल हमारे पास जहां तक possibilities is equal to 31 times 12. We are assuming every month has 31 days, no? Although in reality किसी में 30 होते हैं, किसी में 31, but here we are assuming every month has 31 days. And years we have 100. From 00 से लेके 99 तक. So total dates of birth is equal to 31 times 12 times 100. Fine. इतनी possible date of births हैं. So we have 12 times 31 times 100 possible date of birth. So जहां तक हमारे पास possible entries कितनी होगी? 26 raised to power 8 names. Corresponding to each name we have choices. It could be male or female. And corresponding to each of this choice, we have 12 times 31 times 100 possible date of births. So we multiply all these choices. And then we have 13 possible job responsibilities, job codes. True. Thank you, Zaid. So we have 13 possible job codes. So we multiply each job code with all of those previous entries. So far possible entries are, so we have 26 tests for 8 choices for name, 2 choices for gender, 12 choices for month, 31 choices for days, 100 choices for years, and 13 choices for job code. So we have possible entries in our database: 26 times raised per 8 times 2 times 12 times 31 times 100 times 13. So this becomes something like 10 raised per 9, 12, 15, 18. 2 multiplied by 10 raised per 17 approximately entries. So many entries are possible for this database. In reality, it will be less, but we are just considering the extreme scenario. So let's make a rule. So we make a theorem. इसको अभी हम explain करते हैं. Let's read it first. Suppose that we want to form strings of length n by using any of a given set of k1 symbols as the first element of the string, any of a given set of k2 symbols as the second element of the string, any of a given set of kn symbols as the last element of the string. Then total number of strings are k1 times k2 times k3 up till kn. For example, in last our example that we discussed, so we have total length n possibilities. लेकिन ये कितनी हो सकती हैं? K1 symbols as the first element. So we have 26 raised per 8 symbols of the first kind. Then 2 symbols of second kind. 12 symbols of third kind. 31 symbols, possible symbols of next kind. 100 possibilities of next kind. 13 symbols of next kind. So total strings कितनी हुई? K1 times K2 times K3 times K4 times K5 times K6. So if we have n types of symbols, first type of symbols multiplied by second type of symbols up till nth type of symbol. So we have total, these many possible strings are there. These many possible sequences are there. So far so good. Any question, please ask. If no, so we move to, we just explain one more example. This is the answer, so I removed the answer. How many numbers are possible with 4 digits? अगर हमारे पास 4 digits हैं तो हम कितने numbers बना सकते हैं? 4 digits. So at very first position we cannot have 0. So at very first position we can have 9 choices. 1, 2, 3, 4, 5, 6, 7, 8, 9. For second digit, we have 10 choices because now we have 0 as well there, from 0 till 9. For third digit, we have again 10 choices. For fourth digit, again we have 10 digits. So how many possible numbers we can form? Answer, please. जैद ने तो आंसर दे देना है, कोई और anybody can answer please. तैयब, what could be answer? दावर, आपने कभी इनपुट नहीं दी. इजाज, what should be the answer? Aisha. So how many numbers are possible with 4 digits? For the very first digit, we have 9 choices. I mean, I'm giving you the answer. For the second digit, we have 10 choices. For the Nasir, okay, thank you, beta, that's correct. So we have, for the first digit, we have 9 choices, 1 to 9. For second, we have 10 choices. No, 4 is for 9 नहीं होगा बेटा. So for third digit, we have 10 choices. For fourth digit, we have 10 choices. So 9 into 10 raised to power 3 should be the answer. और यहाँ से हम देख भी सकते हैं कि from 1000 1000 up till 9999, how many numbers we have? We have 9000 numbers. Z 10,000 इसलिए नहीं होंगे because we are not counting the first 1000 digits numbers, क्योंकि शुरू में आपके पास जीरो नहीं आ सकता. शुरू में आपके पास choices 1 से लेके 9 तक हैं. So we are counting from 1000 till 9999. So answer should be 9000. Okay, so let's make it more generalized. How many numbers are possible with n digits? पहले 4 digits था, now we make n digits. So for the very first number, we have 9 options, and for the rest of n minus 1 digits, we have 10 options, 10 digits. So answer should be 9 times 10 raised to n minus 1. Just like in the previous question, we have n is equal to 4, n is equal to 4. So 9 into 10 raised to 4 minus 1. 9 into 10 raised to 3. Okay. So how many numbers are possible with n digits? 9 into 10 raised to n minus 1. Okay, Janab. So far we have done. We are counting number of subsets and we were counting number of sequences. So so far what we have studied, we always multiply our choices. We always multiply our choices. So far we always multiply our choices. So this thing is called something, we called it product rule. This is called product rule. Product rule of counting. Fair enough. So let's do some examples of product rule before we finish off. So I mean, these questions you have to do it by yourself, but we have time, we can discuss. So the question is, a company hires 2 employees, Sachal and Sarmas. We have 2 employees. You can call A and B, Sachal or Sarmas. So we have 12 offices. In how many ways we can assign different offices to these 2 employees? So in how many ways we can make them sit down in the office? हर एक के पास एक office होगा. So for example, consider Sachal. First Sachal comes in. You can turn on mic and you can answer, or you can just type. So first Sachal comes in. We can make him sit down in how many ways? We can assign office to him in how many ways? Sachal can get office in how many ways? Any answer? Any answer? Sachal can get office
12 ways.
12 ways. Thank you. So Sachal can get any of the 12 offices. ठीक हो गया. अब Sachal का एक office fix हो गया. We fix one office for Sachal. Thank you, Nasir. We fix one office for Sachal. तो बाकी offices हमारे पास रह गए 11. So in how many ways Sarmas can get office? So it should be 11. So answer should be 12 times, I write down here. So answer should be 12 times 11. Okay. So next, look at this. Oops, answer should be okay. So in an auditorium, we are going to label chairs, okay, with 3 characters. First character is going to be an English letter, and next 2 characters are going to be digits. So followed by integer not exceeding 100 means we can have numbers from 00 up to 99. So how many chairs can we label? So how many chairs we can label? How many chairs we can label? सबसे पहले हमारे पास एक alphabet आएगा. So how many choices we have for alphabet? And then on second position we have a digit. हमारे पास 10 digits होते हैं. And third place again we have a digit. So how many chairs we can label? Any answer? How many chairs can we label? Answer. बता दे. देखें, first we have character. So there are 26 possible characters. We have 26 choices. A से लेके Z तक. Corresponding to each of this character. Yeah, thank you. 26 for alphabets. Corresponding to each of this alphabet character, we have 10 possible digits. And corresponding to each of these choices, for third place we have 10 possible digits. So we have 26 times 10 times 10. Okay? So answer is 26 into 100, 2600. So let's move to next question. Again, answer, I should remove it. So we have now label the car. उसी तरह का क्वेश्चन है चेयर्स वाला, but we are generalizing it more. So we label with 3 alphabets followed by 4 digits. जैसे लाहौर में आप कार रजिस्ट्रेशन नंबर देखते हैं LALEJ 1418. तो सबसे पहले हमारे पास 3 alphabets होते हैं followed by 4 digits. So how many possible ways to tag a car, to label a car, to register a car? तो कितने possible tags हो सकते हैं? So please answer for this question. How many car labels? How many car number plates would be possible? So any answer? Any answer? Baz? Any answer? Arham? Fahad? 26 raised by 3 for letters, that's true. And Nasir, yeah, that's true. 26 raised power n into 10 raised power 4. N की वैल्यू हमारे पास 3 हो गई ना. So we have, oops. So we have 26 into 26 into 26 for alphabets and 10 into 10 into 10 into 10 for digits. So 26 raised by 3 multiplied by 10 raised by 4. अब बेटा हमारे केस में होता है so we assume कि we have all possible 10 numbers, 10 digits. ठीक है. So count the number of 4s. Easy है, you can do it by yourself. How many different bit strings of length 7 are there? We have already done it. 2 raised per n. So it should be 2 raised per 7. So how many bit strings of length n are possible? 2 raised per n. ठीक है जनाब.